how does it work in our daily business? Again, you can easily see here at the previous ablation line the breakthrough. What I do next is to check to which direction the activation wavefront is going, so which spline is achieved earliest. Check the local signals in addition, of course, so nice kind of fusion of two components. And then I got a quite good idea about how the activation is going to and into the vein. And finally check the spline itself, whether it goes from 8 to 1 regarding the electrode, that it really travels into the pulmonary vein to prepare the setting. And in this particular case, afterwards we documented this tachycardia. Again, we did a map of the left veins, as you can easily see here in the CRS catheter. Sinus rhythm was present, the vein was re-isolated. And personally for me here are two major things to consider. If you look at the cycle length, it's quite fast and it's not completely stable. So we tried to detect the most stable cycle length. And for me it was a kind of eye-opener that even in these kind of arrhythmias, we have some idea at least that a kind of rotational activation is going on. Here in this area we have the collision here at the area that has been shown here. And yeah, the second thing is that, of course, it's always still about fun and even if the confidence mask has to be taken quite tough, here you can, that's what I wanted to show here, you can get a good idea about a gap. So quite obvious, the left inferior pulmonary vein here from the PA view appears isolated, while again we have a nice breakthrough here close to the roof. Yeah, and again here's the ablation set, and here's the tachycardia going on while the basket was in the vein. Here's the atrial tachycardia is running before it terminates here to sinus rhythm, and the tachycardia was jailed. One example where it helped quite nicely. We have now displayed the low voltage area here, kind of high voltage area here, and the activation then running into the vein, because the annotation, as you heard before this morning, is not related especially to the timing, but it displays the whole signal throughout the cycle. Yeah, the fractionation can be easily highlighted with this kind of specific window of interest as discussed before, so that we get a good idea which area to address and where to check the local signals. And this initial experience has nicely been summarized here by our friends from Bordeaux. We also followed the patient series, and there are two things at this given point of time I would like to stress here. First of all, of course, there is a relationship between the generator impedance and the local impedance. And as a rule of thumb, we observed that the drop of local impedance is about twice as high as the drop of the local impedance. However, what was additionally a nice detail is that if we look at the generator impedance at baseline and how it is related to the drop that we can expect during RF delivery, the correlation was weak, and here it appears that we get more details regarding lesion formation from the local impedance at the tip, at the tissue contact where the electromechanical coupling takes place. Just a few examples again. Here you see the activation within the vein, the activation map nicely showing here a gap, and the drop of the local impedance of about 25 ohms. Here the curve shown with the raw data before the right superior vein in this example gets isolated. So this is a nice tool that can be easily integrated in the workflow, of course.